Dressing for success usually means wearing a suit. It's the uniform that's traditionally defined men's economic roles. And as women have achieved success in the work world, they've done so in their power suits. The basics of the suit have been unaltered for over a century. A jacket and trousers or skirt. It's a look that's never out of style. Every suit has to look good on paper first. So a designer sketches a style. It's a creative process, but also highly technical. He plans the entire outfit, right down to the last stitch. No detail is left to chance here. They feed the design data to this computerized cutting machine. The C-blade slices through fabric placed under paper, and because it's computerized, it's very precise, producing pieces that will fit together like a puzzle. This is how they used to cut the fabric, by hand. It was more time-consuming, and the margin for error was much greater. Now it's time for some reinforcement. She places fusing tape made of fabric onto a sleeve piece, and then sends it to a heat chamber with rollers that will bond the tape to the material, giving it strength. Next, it's over to the sewing machine. A worker lines up 2 sleeve layers, and it's hands-free from here. A rail powered by compressed air descends and guides the fabric under the needle. A computer controls the sewing. This frees up the operator to continuously feed the machine. This is an automatic pocket welt machine. It makes pockets. She places the front of a jacket under a clamp and puts the welt fabric in the clamp and a pocket flap at the side. The clamp automatically slides the fabrics to needles that sew the welt and flap onto the jacket. Then 2 tiny knives emerge and cut the pocket open. The result? A precisely made pocket, completely by automation. The only human involvement is to feed the machine and then collect the finished product. Now, over at another station, an operator irons fusible tape onto the open seams. This stabilizes them and gives them a crisp finish. A worker places the front of the jacket on a headless mannequin called a buck. A hot metal press moves in, and the pressing reshapes the jacket to the contours of the buck. Now, she puts a sleeveless jacket on another buck and tucks a shoulder pad underneath. She presses a pedal to activate the machine, and the hot presses lower, melting the glue on the shoulder pad, which fuses it to the jacket. Now things are about to get really steamy. Another jacket is on another mannequin, and a worker clamps down the sleeves. A big steam bag made of porous vinyl swings in, wafting steam onto the front of the jacket. At the same time, hoses pipe steam into the porous mannequin cavity, so this jacket gets a steam press from both sides. This machine is a collar master. She folds the collar into the correct position and lowers a big fabric-covered metal press onto the collar to iron down the fold. It's time for the auto jig machine. It's making an extension piece to the second button for a pant waistband. This is the piece that goes over to the second button on the waistband of dress pants. It sews and cuts 2 layers of fabric that are held in a jig, and then feeds the excess fabric to a vacuum tube for disposal. Now it's time to define a crease in a pair of trousers. An operator slides a pair of pants, inside out, onto a double rail. Then, using a device similar to a caulking gun, she pipes a silicone-based liquid along the crease line. The liquid is a perma-crease mixture, which will give the crease some staying power. There's also a nib on the end of this gun, which sharpens the crease. All that stitching and steaming seems to have gone without a hitch. But the designer still needs to inspect the work to see if it measures up to his original concept. If adjustments have to be made, he marks the spots. After all, if the suit looks good, he'll look good. And you've got to look good to feel good.
Lapel pins let you proudly show off where you've been or where you stand. From an event you've attended or your political beliefs to your professional affiliation or your favorite sports team. Lapel pins cost pennies to produce, but some are collector's items worth thousands of dollars. They may be tiny, but they're out there in huge numbers. This one company turns out about 5 million lapel pins a year. It all starts with a sketch of the pin design, and from that, the master, a negative made of magnesium, a type of metal. They'll make copies of this master to create a production mold. But first, using what's called a coping saw, they cut out the front and back pieces of the master. Using a dispenser about the size of a sewing needle, they glue the pieces together with epoxy. It takes 5 minutes to dry. Then they cast enough copies of the master to fill up a rubber disc. After tracing the outlines, a worker uses a surgical knife to meticulously carve out the cavities. He softens the rubber with paint thinner to enable precision cuts. Then he places a copy of the master in each cavity. Another disc goes on top. Then it's into a machine called a vulcanizer for 1 hour. This machine uses heat and pressure to cure the rubber, making it as hard as a car tire. It also melds the rubber around each master copy, embedding the detail. This will be the production mold for producing this pin design. Now, using a surgical knife again for precision, they carve out sprues, channels that during the casting process will direct the flow of molten metal to the cavities. They also make smaller, curved channels called runners to filter out any air or dirt particles. It's crucial to position the sprues and runners correctly because this mold produces an entire line of a particular pin. Mess up and they'd have to remake the mold from scratch. Next, they insert a centimeter-long brass tack called a post into each cavity. It'll later fasten to a clasp, attaching the pin to clothing. The post goes in now rather than later so that it will fuse to the back of the lapel pin during casting. Now to close the mold, they align the buttons on one half with the depressions in the other half. The mold then goes into what's called a spin casting machine. Using a cast iron ladle that can withstand the fiery temperature, they pour in molten metal, either pewter, zinc, or a tin alloy. As the machine spins, centrifugal force propels the metal into every nook and cranny of the cavities. After a minute of spinning, 400 rotations, the mold comes out. The metal takes about 5 minutes to cool and harden. The factory remelts the excess metal for the next batch. Next, a brass clasp called a clutch goes onto the post. Now the lapel pins go for an hour-long wash in soap and water and abrasive stones. The stones smooth out any rough edges. The pins go into the electroplating tank for a surface coating of metal. How many coats and the types of metal vary with the design. An electric current draws the metal particles onto the pins, plating them thoroughly. These pins first get copper plating, then nickel plating, then gold plating. Now it's time to paint the lapel pins. Workers follow a numerical guide like a paint-by-numbers kit. They paint each pin individually using minute quantities of epoxy paint. They control the paint syringe with a foot pedal. Once the paint dries, a machine called a pad printer gathers up ink and stamps on the tiny details, the ones too small to paint by hand. Pierce the post through the fabric, secure it with the clutch, and this lapel pin is now ready to wear.